Question 1 of the practice exam is actually already covered in exam 1, so you don't have to do number 1, so we're going to start from number 2. Here the question says, explain how the graph of y equals to negative square root of x minus 3 minus 4 can be obtained from the graph of y equals to square root of x. It says, give the transformations. And apparently from that, you can use the information from A to sketch the graph of the function. And from the graph, you can also figure out the domain and range. Okay, let's think about this. Now, let's think about each of these numbers attached to the function. So first of all, this minus, what does that minus do? If you have a minus in front of the function, what does it do? It flips which direction? Upside down, right? It flips upside down. So this one here flips over x-axis. See, x-axis is this, so if you flip over the x-axis, that means it's flipped upside down, okay? How about this negative 3? What does that do? Minus 3. If you replace x, yes? No. Go right 3. If you replace x by x minus 3, this makes it go, it moves right by 3. Okay. And what about this minus 4? That one makes it go down 4. Okay. This moving right by 3 and going down by 4 can be thought as a single transformation, which is called a translation. And a notation that we can use is t of 3 negative 4, although I never used these notations in class. If you have seen these in high school, in the high school math, you probably were asked to write your answer in terms of this way. You could write it this way, I'm fine with it, but you can just say move right by 3, down by 4, that's fine with me as well, okay? So that's this is called translation. And flipping over the x-axis has a notation called small r of x. So if you do small r of y, that means you reflect over the y-axis. Small r of x means you reflect over the x-axis. So we have these basically two transformations that are given by these things, minus negative 3 and negative 4. Okay. Now the question is, which order should these transformations be applied to y equals to square root of x? In other words, I'm thinking of y equals to square root of x changed by some transformation to another function, and then eventually it becomes y equals to this negative square root of x minus 3 minus 4. And because you only have like two transformations, you have to decide, should we reflect and then translate, or should we translate and then reflect? Which do you choose? You want to do reflect and translate? Okay, so let's see if that works. Now, I mean, we could try to come up with some kind of algorithm to figure out which is which, but I don't really find anything that's effective. And it's really one of the two, either this first and that, or this first and that. So it's just try both and see which one works. If one works, then you stick with it, then you don't have to care, okay? So if I reflect over x-axis, let me see, reflect over x-axis, then what happens to the equation? You put an overall minus sign, right? That's how you reflect over the x-axis. entire thing reflects. Okay, and now you move right 3, down 4, and that movement gives you this, and that's the answer. Okay, you take this one, and moving by 3 to the right means you replace x by x minus 3, so that's what happens. And then down 4 means you just subtract 4 off the entire function. So that's what you get. Okay? All right. So out of curiosity, let's see what happens if we did it the other way. Okay? And don't write this second one down because you're going to just confuse yourself if you read the notes later. So what if we started with y equals the square root of x and shifted 3 right and minus 4 down? Let's see what happens. If you do that, then you have y equals the square root of x minus 3, right? Minus 4, right? Replacing x by x minus 3 makes it go right by 3. Subtracting 4 makes it go down by 4. So that's what you get. Okay. Now let's see what happens if you reflect over the x-axis. If you do that, then you have to apply the minus to the entire function, right? That's what you get to reflect over the x. And the problem is you get this minus has to be distributed, and you get minus square root of x minus 3 plus 4. And therefore you get a plus 4, which doesn't match with what's given. This has to be minus 4. Right? So that's why it doesn't work. So if you try to do it, you see that you have to do the reflection first and then translate. If you do it the opposite, if you do the translate first and then reflection, you don't get what you want. Yeah. Now, there is an elaborate way to make it still work, even if you do translate first and then reflection, but that's harder to think, so I don't advise you doing this. But let me show you it anyways. Okay, so if you instead move up by 4, then this will be plus, right? And then reflection over x-axis would introduce a minus to everything, and you do get a minus in that case. So maybe someone could have figured out this way, but this is not so not that advised because it's harder to think. Okay. All right. So this thing that's written in black will be the answer to question part A. Now let's see how you can draw the graph using these transformations. So now it's asking us to draw the graph of this function. And you have to start with the graph of y equals the square root of x, which is one of the graphs that you have to memorize. Okay, you have to memorize the graph of square root of x. Can you draw the graph of the square root of x on the air? What do you think? Try to draw it. Something like that, yeah. Right. So it's like this, right? That's the graph of y equals the square root of x. It doesn't fall down, it just keeps going up, except that the growth slows down, but it never slows down to 0. It always grows up, okay? So it's a forever increasing function. Yeah, this is y equals the square root of x. Okay. Now let's think about what happens if you put a minus. What does the minus do? Flips over the x-axis. So you get this as y equals to negative square root of x. Okay. And then furthermore, this thing is now shifted 1, 2, 3 steps right, and then 1, 2, 3, 4 steps down. So you have the final answer as this guy. So this is the graph of y equals to negative square root of x minus 3 minus 4. And this is the answer. And it's good to have the coordinates of this point. This will be 3 comma negative 4. That would be the point, the beginning point of this curve. Any questions so far? All right, now another question. What are the domain and range? Okay, what is a domain? Can somebody answer? What's a domain? Yes. Yes, x values, the input values, right? Yeah. What's the range then? All the y values, right? So what you have to do is for each point on this curve, you have to look at its x coordinates. So what's the x coordinate of this point? 3, right? Now I don't know the x coordinate of this point, but it will be bigger than 3. Don't you agree? Yes, very good. So the domain here would be, D would be 3, including 3, to positive infinity. Okay, now let's look at the range. Range means the y values. So at this point, in the beginning point, what's the y coordinate? Negative 4, and then what happens? Keeps going down, so it keeps becoming negative, right? Okay, so it goes down to negative infinity. So how do you write it? Range is? Huh? You have to always start from the smaller number first. So you have to start with negative infinity, okay? And then 4, actually negative 4. Negative 4. If you switch this around, then you don't get full credit, okay? Yeah. So the answer is negative infinity to negative 4, close bracket. Okay, so that's the answer to part B. Now, before I erase this solution, let me just make one more comment. How would you draw if you follow this second one that was harder to think? It's saying that we should first move 3, but instead of going down, you go up. And then that's where you draw this curve, right? So this curve right here is y equals the square root of x minus 3 plus 4. Okay. But then the next thing that we do is we reflect over the x-axis, right? So imagine reflecting this over the x-axis. If it goes up there, this will be brought down to here. So you end up with the same answer. Okay? And of course, even if the transformation order is different, this does give you the same thing, right? If you change the 4 down to 4 up, right? And therefore, you should be getting the same answer, okay? Yeah. So I just wanted to point out that although this is harder to think, not advised, but if you did it this way, if it's correct, you should get the correct answer. Okay, this question is about a piecewise function. And a piecewise function has 2 parts. One is, this portion is the conditional. And this other part will be I'll just say that this other part will be formulas, okay? Formulas will be the other parts. And it works like this. You have different formulas to evaluate, but you evaluate the formula only when your x value satisfies the conditional. And let me explain what I just said by doing an actual problem. So let's think about A. A says, what is f of 0, right? Now, when that is being asked, f of 0 means 0 is taking the place of x. Does that make sense? So maybe I should stress this. This right here means 0 takes place of x. Maybe I should write this bigger. F of 0, 0 takes the place of x. Okay? And therefore, in every x on the right side, you should be replacing x by 0. Is that okay? Yeah. But 0 takes the place of x, right? On the right side. Here, this x is 0, this x is 0, this x is 0, this x is 0. All of these are zeros, okay? But then, before you actually evaluate the formulas, what you have to do is you have to test the conditionals. So, is 0 less or equal to negative 1? Yes or no? Is 0 less than negative 1? No. Is 0 bigger than negative 1? Yes. And because that's true, the formula that has this true is going to be evaluated. And what was this again? This is 0 minus 1, right? Yeah. So, therefore, you end up saying that this is equal to 0 minus 1, which is negative 1. Is that good? All right, so now let's think about the second part as well. What is f of negative 3? Again, what does this mean? Negative 3 replaces x, right? Yeah. All the x's here are replaced by negative 3. Okay. But then let's look at this one. Is negative 3 less than negative 1? Yes. Is negative 3 bigger than negative 1? No. So it's this one that's true. Therefore, which formula should we evaluate? The top one, okay? So we're going to be putting negative 2 times negative 3 plus 3. Now, it's a good practice always to put a parenthesis. Even here, I should really have had a parenthesis. Anytime you're plugging one thing into another, try to have a parenthesis because often that will save you from making terrible mistakes, okay? So I have a parenthesis here, which tells you that these two things are multiplied, not subtracted, okay? If you don't have the parentheses, it's easy to fool yourself thinking, oh, it's negative 2 minus 3, which is negative 5. But that's not what we're doing. Negative 2 is multiplied to x, right? So when x is replaced by negative 3, you're multiplying negative 2 and negative 3, which is positive 6 plus 3, which is 9. So that's the value. Okay, although this is not asked, let's just do one more. What is f of negative 1? Let's see if you understood it.
Replace all the x's with negative
1. Okay, and then?
It's the top one.
It's the top one, yeah, because negative 1 is less or equal to negative 1. So this is true, and therefore we evaluate the top one, which means negative 2 times negative 1 plus 3, what's that? 5. Yeah. So that was not asked in the question, but I just threw it out there so that you can, I can make sure that you understood what was going on. Okay? So it seems like everyone understood what's going on. Good, good. All right, now let's graph it. Okay. Now graphing is a whole different business. It's another challenge. So the method I would like to propose, the method I would like to advocate is just graph these two separately and then think about where it's valid later. So just think about the two graphs. So let's think about y equals to negative 2x plus 3. Now, what's the slope of this line? Negative 2. What's the y-intercept? 3. Okay. So y-intercept is 3, so it's 1, 2, 3. 3 is your y-intercept. And then if the slope is, if m is negative 2, you can think of this as negative 2 over 1, which is rise over run. So you can draw it like rise is -2, so you go down by 2 and you run by 1. Okay. This is the next point. And then if you have 2 points, we all know that y equals to mx plus b form is aligned, right? The graph of such a function is always aligned. So if we know 2 points of a line, we know the line. You just have to connect the 2 points using a straight line. And that's the graph of y equals to -2x plus 3. Okay? All right. On the other hand, let's think about the second graph. What about y equals to x minus 1? What's the slope? It's 1 times x, right? So m is 1, which should be thought as 1 over 1, and that is rise over 1, right? So rise is 1, and run is 1. Okay, what is this -1? What does that tell us? -1 tells us the y-intercept, right? So here's -1. That's where the graph begins. And I should have made it slightly lower. Sorry, somewhere here. It's helpful to draw a correct graph just for your own sake. If you draw the wrong graph, often you get misled. So I have this as 1, so that must be 1. Now, to get rise as 1, you go up 1, and then run as 1, so this is your next one. And since these are the 2 points on the line, I connect them, and this is my graph. Okay? So I have the first one drawn in orange. Doesn't look, it's hard to see, sorry. I should have brought another marker. And then blue is the graph for x minus 1. All right. But then something is happening at -1 and 1. -1, right? -1 is like the transition from one function to the other, right? Before -1, you use -2x plus 3, but after -1, you have to use x minus 1. So because -1 is a transition point, what you're going to do is mark -1 right here, and then draw a dotted line, which says only one of the graphs should survive on the left side of this dotted line, and only one should survive on the right side of the dotted line. You get that? Okay. And on the left side of the -1, which should survive, the orange line or the blue line? On the left side of -1. Orange or the blue? How many of you say orange? How many of you say blue? How many of you say orange? Left of -1. Left of -1 is this one. X is less than -1. So the orange one is the one that prevails, right? We use this one on the left side of -1. So what should happen is you should delete the blue on the left side of -1, right? And keep the orange. Okay. On the right side of -1, what should be kept? The blue one, right? The blue one is kept because if when x is greater than -1, it's this one that we evaluate, right? So we're going to keep the blue and delete the orange. What did you say? What's the question? Yeah, just draw the line and then delete. So this reminds me, you should try to bring a pencil with an eraser at the end for the exam, next exam, because it will be handy for doing this. If you don't have it, then you should really draw it in 2 steps. Draw this with both of them present, and then think about which one should be deleted and make a new copy of the one that only has the survivals. Okay. All right. Now, are we done? Not exactly. We still have to manage to say what happens at this actual -1. At exactly -1, we found out that the value is 5, right? Where is that? -1, 5. Here's 5. Here's -1. This point right here is -1, 5. So this point is the actual value of the function, whereas this point is not. It's a fake value, right? Yeah. I put an X there because it's wrong, but that's not the right way to draw this on the graph. How do you indicate that this is not the value and this should be the value? What do you put here? You put an open circle, right? You put an open circle. So you put a circle with nothing in there. So this is a closed circle, a filled in solid circle, and this is an open circle where it's there is no fill inside. Okay, so that's the correct answer. The correct answer will be an open circle here with this, and closed circle here with this. And it's also helpful to know the coordinates of this. Now, if you want to know the coordinates of this, you would plug in -1 to the illegal one. See, this is not the true value. If you plug in -1 into this x, this like x is being fed the value of -1 into the second one, then you have -2, and that's the legal value. -1, -2 is the value that shouldn't be used. -1, 5 is the actual value that should be used. Right? And then this is full credit. Okay. Find f composed with g of 2. Now this small circle is not O. It's easy to read that as fog of 2. What does that mean? No, that's not what it means. It's f circle g, where the circle is a way to talk about the composition of functions. It's about applying one function and doing the next. So the real meaning of this f circle of g of 2 is that inside f you put the g of 2. That's what it means. Okay. You apply g to 2, and then to the outcome of that number, that output of the g2 gets plugged into f, and you compute again what f of that number is. Okay. It's different from multiplication. Okay. You might have something like fg of 2. In that case, this is f of 2 times g of 2. That's what it means. If you don't have any circle there, that's what this means. Okay? And this simply means you figure out what f of 2 is, what fg of 2 is, and you multiply the two. That's what fg of 2 is. Right? Okay, so how do we figure this out? Well, first, what is g of 2? G of x is 2x squared plus 1, so what? 2 squared plus 1. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. Right? Okay, so because of this, we can now say this is same as f of 9. All good? How do you do f of 9? Yeah? 9 into this x, right? So you put 5 times 9 minus 5. And as I said, it's always a good practice to put a parenthesis whenever you plug in, okay? So don't just write 5, 9 minus 5. It's 5 times 9. And one way to make sure that you do that is put a parenthesis. Okay, 5 times 9 is 45. Minus 5 is going to be 40. Okay, B. F over g of 2. What does that mean? This is simply another way of saying f of 2 divided by g of 2. Okay. So maybe I should stress this. This equals sign here, and this equals sign. These are definitions. Okay. Whenever you see circle, without asking anything, you always change to this, okay? Without asking for the context of what f is or g is, this is always that, okay? And this is, again, the same idea. If you are asked what's f over g of 2, without any context, you can always write this as f of 2 over g of 2. Okay, so that's a definition. What is f of 2? It's 5 times 2 minus 5, right? Okay, what's g of 2? 2 times 2 squared plus 1. And then 5 times 2 minus 5 is, did I put? Oh, sorry. The question was not 2, but negative 2. Yeah, I remember doing this problem. Sorry about that. The original question on the practice exam was calling for f over g of negative 2, not positive 2. Okay. All right. So we're plugging in negative 2 to both x. What's 5 times negative 2? Negative 10 minus 5. What's negative 2 squared? If you square a negative number, it becomes positive. So positive 4 times 2 plus 1, you get 9. And therefore, this is negative 15 over 9. I see that both 15 and 9 are divisible by 3. So if you reduce it, what do you get? Negative 5 over 3. Yeah. If you divide top and bottom by 3, 15 divided by 3 is 5. 9 divided by 3 is 3. So that's what you get. Okay. Now let's think about what f composed g of x is. Again, without trying to see what the problem is asking, what the first thing that you have to do is to change this circle into one function plugged into the other. Just change f and g and put a parenthesis between them, okay? So that g of x goes into f. If you do this, then now you have to start asking by what is g of x? G of x is 2x squared plus 1. Isn't this right? Yeah. And one thing you have to know in math is that in math, if two things are equal, then you can always replace one by the other. In real life, that's not true, right? Some things have sentimental values. Like if you lose your teddy bear that you've been sleeping with for 17 years or 18 years, then it would be horrible, right? Your parents buying you another teddy bear is not going to console you, even if it's the same thing. But in math, if two things are same, there's no sentimental value to anything. It's just you just replace one by the other. Yeah, it's cold and harsh. Right? Gx, same thing as 2x squared plus 1, replace, done. Right. Okay, but now the problem is, what is f of 2x squared plus 1? Now this one I need you to think. Give me an answer. Yes.
So would it be 5 parentheses 2x squared plus 1, like outside of parentheses minus 5?
That's correct. That's what this means, okay? Because you're replacing this x by 2x squared plus 1. That's what happens. Now, if you got it, wonderful. Now, if you didn't get what we just did, then I propose a two-step method to go about finding this. Okay? How do you find this? Well, the two-step method goes like this. You start from the definition of f of x equals to 5x minus 5, right? But what you do is you're going to, the step one is to delete all the x and replace the x by parentheses. That's step one. Got it? Step 1, delete x, replace all the x's by parentheses. Step 2 is going to take this thing you prepared and write in on the left side whatever you need to be written in. 2x squared plus 1 is what you need to write in, right? So you're going to write down 2x squared plus 1 on the left side. And that obligates you to do something on the right. What should I put it here then? Exactly the same thing, because I put in this parenthesis 2x squared plus 1. You better be placing 2x squared plus 1 into the other parentheses as well. You get that? Right. So this is replaced by 2x squared plus 1. Okay. And that gives you 5 times 2x squared, which is 10x squared. 5 times 1, which is 5, minus 5, and that's equal to 10x squared, right? Yeah. So we see that the final answer to this is 10x squared. Is this okay? I really need you to do 2 steps. If you want to avoid making mistakes, it's good to do these kind of questions in 2 steps. Okay. Let me try to strengthen that point by doing question D. So let's see what question D is saying. Question D is asking you to do g of x plus h minus g of x. This is something that appears in the calculus, the course that you're going to take after this. Most of you, not all, but most of you will take calculus after this. And if you take calculus, you're going to see something like this. That's why I have it on this exam. But anytime I put this on the exam, the first response is many students will be staring at this with a blank stare. It's like, yeah, obviously they don't know what to do, okay? And out of desperation, I see so many different approaches to this. Some people would say, oh, this must be same as g of x plus h. Some of you might write, oh, it must be g of x plus g of h. Unfortunately, they're both wrong, and you're not going to get any points if you do it this way, right? None of them are right. Instead, to do this one correctly, you just have to apply the 2-step method, right? So let's try to apply the 2-step method. Okay, so first goal is to figure out what g of x plus h is. Well, you start out by writing the definition of g of x, but instead of copying everything, anytime you see an x, you're just going to replace it by blank parentheses. That's step 1, right? Okay, I'll give you a minute to think about what you should do next. What's step 2? Okay, 2 steps, okay? So what's step 1? You copy the definition, right? But anytime you see an x, you put a blank parenthesis, okay? And then on the left side, this is the question, right? I want to know what g of x plus h is. So what should I write over here? X plus h. If I put x plus h, then they're the same thing, right? But that makes me obliged to put what? X plus h. That's what it means. Okay? All right. Now let's continue with this. If you expand this, this is x squared, h squared. There's something in between. What is this thing in between? What's the thing in between? 2xh, right? Yeah. You need that. Where's that coming from? Well, I yelled and screamed several times in this class to say a squared and then b squared, and then there's something in between, right? What's in between? 2ab, right? And I kept screaming, double what? Double the product. See, product means multiplication. So you multiply a and b, right? And you double it, double the product. Okay? So I kept saying double the product, and I feel like I need to yell at you, double the product probably 20 more times until the end of the semester, until you really get it. But you need this, okay? You get the double the product. So if you have x plus h squared, it's x times h times 2. That's in the middle, right? Okay, and then let's multiply the 2 to every one of these. So that's going to be 2x squared plus 4xh plus 2h squared plus 1. And that allows you to now answer this. Since this gx plus h is 2x squared plus 4xh plus 2h squared plus 1, and then gx is this thing, right? So we subtract 2x squared plus 1. Okay, I just made a mistake. What's my mistake? What's my mistake? You don't know what my mistake is? That's my mistake, okay? Yeah. Not having the parenthesis is wrong, okay? Yeah. You need a parenthesis. So always when you replace one by another, substitution, plugging in, you need this parenthesis. Okay? Missing that would often lead you to wrong answers. It's bad. Okay? And therefore, this is going to be 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1. And then as you see, 2x squares cancel. And then the 1's cancel as well. And at the end of the day, what remains is 2x squared, 4xh plus 2h squared. That's the final answer. Okay, this is a question where you have to read off the values of the function, the output of a function from the graph. So for example, what's g of 1? This is 1, 2, 3, 4, 5, 6, okay? So g of 1 is 1. Agreed? Okay. What's g of 2? 5, because it has 2 comma 5 as the point of the graph. If you have 2 comma 5 on the point of as the point of the graph, that means when you plug in 2 into the g, then the output will be 5. Okay? Right. And apparently these are made up of straight lines. So you have to figure out the values by using the property of straight lines. All right? So first of all, let's think about f circle g of 3. What does this circle mean again? What does the circle mean? Parenthesis g of 3, right? Just like that. Okay, what is g of 3? Well, we don't know because it's this value, right? 3 comma something. But what I do know is that 3 is the midpoint of 2 and 4. Agreed? Yeah. And it's a property of the line that if you have 2 given points and there's a midpoint, then both x and y coordinates are midpoints. Since the x coordinate is the midpoint, then the y point should be also the midpoint. Okay. What are the y coordinates? 5 and 3. What's the midpoint of 5 and 3? 4. How do you calculate midpoints? How do you calculate midpoints? Yeah, you just add the two, 5 plus 3, and divide by 2. You calculate the average. Average is the midpoint. Isn't that right? Yeah, if you have two numbers, calculate the average, you get the midpoint. Right? So if you calculate the average of 5 and 3, 5 plus 3 is 8. 8 divided by 2, you get 4. So because this point should be 3 comma 4, it must be f of 4. Now, what is f of 4? Well, that takes a bit more care. See, we're trying to figure out what this is. But this portion is a straight line, so let's think about the slope of this curve, this line. It went from negative 2 comma 2 to, what is this coordinate? 3 comma 0. So from negative 2 comma 2 to 3 comma 0, what's the, negative 2 comma, sorry, this is 2 comma negative 2. I wrote it wrong. 2 comma negative 2. From 2 comma negative 2 to 3 comma 0, what's the rise? Rise meaning the change of y. Y went from negative 2 to 0, right? What's the change of y? Positive 2. Right? Okay, what's the run? Run is the change of x, right? It went from 2 to 3, it increased by 1, right? So the run is 1. So what's the slope? 2. Yeah. Now that means if you want to know this next point, you just have to do it again. You do rise by 2 and run by 1. What is this coordinate then? If you rose by 2 and run by 1, what is this new coordinate? This is 3 comma 0. The new coordinate is 4 comma 2. Right? It's 4 comma 2. You see that? Go up by 2, run by 1. Since it was 3 before, if you run by 1, it will be at 4, right? And you go up by 2, that's 2. Y coordinate is 2. Is that good? Right. So that's going to be 2. F of 4 is 2. All right. Let's do the other one. G composed with f of 3, which means G of f of 3. That should be automatic. It's always, regardless of the question, anytime you see a circle, just rewrite it as parentheses. What's f of 3? Well, we did it before. No, f of 3 is here, right? What's f of 3? What's f of 3? 0. So it's G of 0. What's G of 0? Look at the graph of G. G of 0 is 1. Yeah, it's 1. Right? At 0, this is 0 comma 1. So G of 0 is 1. What's the formula? Don't look at the notes. Don't do that. Yes. H equals to negative b over 2a. Yeah. Where is this from? It's from the quadratic formula, right? In the quadratic formula, you delete the square root part, and this is what you end up with. That's what I explained, right? So it shouldn't be that hard. If you can remember the quadratic formula, this should be a bonus. Okay, then let's see. What is b? B is 12. See, it's A, B, C. So A is negative 3, B is 12, C is negative 8. So A is negative 3. This negative and this negative will cancel. So you just get 12 over 2 times 3, which is 12 over 6. What's 12 divided by 6? 2. What's K? K, how do you get K? You plug in the H that you just figured out. So this 2 right here goes into the function, f of 2. Okay. So maybe I should write this 2 in blue, and that's where this 2 comes from, okay? F of 2. That means every x that you see replace x by parenthesis, right? And then what do you write in? 2 is plugged in. Okay. Yeah, I beg you to put parentheses, okay? You're a bad student if you don't have the parentheses. Okay? You don't make a bad impression by doing this in your exam. Always put a parenthesis, all right? Okay, minus 3. 2 squared is 4. 12 times 2, 24, minus 8. Negative 3 times 4 is negative 12 plus 24 minus 8. You have a question? You have a question? It's square first, and then you multiply. Okay, all right. I thought that was your question. Okay, negative 12 plus 24 is 12 minus 8, that's 4. So 2 comma 4 is the vertex. So the answer to this part, first part is 2 comma 4. Now the question is this vertex max or min? Maximum point or minimum point? Why is it maximum?
Because it's a negative.
It's the a value here is negative. If a is negative 3, that's negative. And what do you know about negative a? The graph would be opening down. It will be upside down. It will be opening down. So here will be the vertex 2 comma 4, and the graph is going to open down like that. And in such a case, the point would be maximum, right? Yeah. So because of this graph, it will be a maximum. Because a is less than 0. Okay.
Once it's explained, should we just draw a graph?
Yeah, just say this is the graph because a is less than 0. And this is enough. If I see this, I'll give you full credit. Okay. Yes?
So when the coefficient is negative, that means it's an max, and when it's positive, it's a
Yeah, that's what's going to happen eventually. Yeah. Okay. Now, what's the domain and range? Domain is? Huh? All real numbers. How do you write that in interval notation? Negative infinity to infinity. Now, in fact, if the domain is being asked and you have a polynomial, right? Meaning that you don't have any square roots or fractions. If you have something like this, then always the answer is all reals. Yeah. Even during tomorrow's quiz, it will be the domain will be this. Okay, and that's 1 point. If you write this, that's 1 point, right? That's a good thing, right? Yes.
So it's because the vertex is 2 and 4, which is whole numbers. That's why.
No, that has nothing to do.
That's for range.
Yeah, that's the vertex has something to do with the range, but the domain will always be negative infinity to infinity. If you have any quadratic function or cubic, quartic, any polynomial of any order, in such a case, the domain is always all reals. Okay. Now, if you have a square root, or if you have something over something, and in the denominator you have x, then there are problems with some inputs, right? You can't have 0 in the denominator. You can't have negative inside the square root. Those cause problems. But what's range? Range is all the allowed numbers you can plug in, right? There's no prohibition to x being anything here. You can always compute, right? So domain is all reals. Yeah. So write this thing and get 1 point from the quiz tomorrow. Yeah. Yes, you have a question? Okay. Okay, now the range. The range, what is that? Yeah, since 4 is at the top and it only goes down, you get all the negative numbers and everything below 4. Do you agree? Yeah, and 4 is included because it does get, if you plug in 2, you do get the value of 4 as the output, right? So you start from negative infinity and you can go up to 4. Close bracket, but not anymore. This is the most you can get to. All right? Okay. That's all for